Hello engineers, this is Dana from Structural Engineering World. This is the first video in our course, and in this video we will analyze a simply supported beam in Autodesk robot. As you can see here, this is the beam that we want to analyze. It's a simply supported beam, as I said. The length of the beam or the span is 6 meters, and we are applying a 15 kilonewton load, a concentrated load, or some people call it point load. We are applying this point load on the beam in the center. So the point load is 3 meters away from the support. As we can see it here, we have a pin support on left and a roller support in the right side of the beam, which means this is a simply supported beam. And also it means this is a statically determined beam or system. Okay, now let's start to analyze the beam. As we can see here, I'm using Autodesk Robot Structure Analysis Professional 2022. So when we open the software, we will have a lot of options. As you can see here, 3D and 2D and plate, slab design and shell design and this thing. In our case, we are analyzing a 2D beam. Then we will choose this one, 2D frame design. Okay, now as you can see, this is the interface of the software. There are some familiar icons here. As you can see, new, open, save, and they are very simple. I don't have to explain them. The part that I want to explain is actually this part here. So we have start, nodes, members, section and material, supports, and loads. I think after seeing these parts, it's very clear what you will do. First, we will start from nodes, then we will draw our member, and then we will assign our section and materials if we have, and we will add supports, then we will apply the load. So in our case, we have a general beam, so we will not have any section and material. So the software will apply a section and a material for our beam, but we will ignore that, so it will not affect our result. Let's start with node. And here, when we are in node, we can see that this is our worksheet. We have, as you can see on X, we have 0, 20, 40. We can zoom in, it will be 0, 10, 20. Also, we have the same thing in Y direction. Or let's say this is X direction and this is Z direction. As you can see it here, this is X and this is Z direction. But if you notice here, you have feet. So this is very important. You have to decide what's the unit that you want to use. To change the unit, actually I'm going to use a meter. So just click here in this corner. You can see it's written feet, keeps, and degree. So click on them, and you will see this window. In this window, click on the first part. It's written units and formats, and click on metric. I'm using metric. If you want to use imperial, it means feet, and the American system, just click on imperial. So metric, okay, and that's it. So I want to choose my center point. So let's go here. Okay. So this is 0 in Z direction and this is 0 in X direction. Let's choose that. You can choose any point, but I like to choose this point to start on. As we can see in our picture, the beam is 6 meters long. So this is 0.00 and this is 0.60. So let's go. Okay, as you can see here, we have 10. Let's zoom in. When you zoom in, by the way, I'm doing zoom in and zoom out using the roller of the mouse. Okay, but you can do it in view. You have zoom and zoom in and zoom out. You can do that if you don't have a mouse. Okay, so as you can see, when I move my mouse, you can see here, this is our dimensions or coordinates. But I just noticed that my system still is in imperial. And let's see why is that. So let's click on meter. Yes, I want, yes, and okay. Okay, now it's meter. Okay. And then let's go for 6. As you can see here, it should be 6 and 0. So click on 6 here. This is our second point. So we have 2 nodes or 2 points. Okay, now let's draw our beam. To draw a beam, we can go back to start. I prefer to do that. Okay, we barely can see the pointer. Do you see it? This is 0.2 and this is 0.1. Okay, let's stay here. It's red. I don't know if you see it. Do you see 0.1 and 0.2? So let's go to geometry and we want to draw an object. So in drawing object, we have these options: arc, circle, rectangle. So we can draw these things. And as you can see here, we have this option here to draw a member here. Okay, so you can go, if you have complicated geometry, you can go to geometry and here choose something, for example, panel or object or beam or something. Okay, but we just want to draw a simple like a simple line or a simple beam, so we can click directly here in this icon, members. Here we can choose some properties of our section, but we don't want to do that. And because we are using a general beam. So where's 0.1? This is 0.1. Click on 0.1. Okay, and do you see that arrow? Go to 0.2 or 0.2. It's here. Click on it, and here we have the beam. So we can close this window. Now we have the beam. As you can see, we have it here. If you see, this is the outline of our file. Here we have our objects. So first we have nodes and members. In nodes, we have node 1, it's green, do you see? And node 2, this one. In member, we only have one member. So member 1, node 1, node 2. Now let's go to the support. We need to draw the support. Okay, in the support, as you can see, here we have fix, pin, and roller. So we want to have a simply supported beam. So we will have a pin support there and a roller on the right side. So let's go for pin. Click on pin support and then click here, and now we have a pin support here. Then click on roller and click on the second support here, and now we have roller. So this is pin and this is roller. Now we have the beam, we have the supports. The next step is to apply the load, which we have 15 kilonewton. In this case, I will go to the section of lots. So I will repeat it. We started from node, then support, then to lots. Let's go to lots. Here we can see that we can see this window down. I will try to Here we can see the list of our lots. Here we can define our lots type. So let's say we have dead lot, we have live lot, we have self weight, and these things. We can define them. And here we will have the applied lots. Let's add any type of lot. Okay, so our our lot here, let's imagine this is a dead lot. So let's keep the name as default, DL1. Let's add that. When you add dead lot, you have to know this one. In robot, always when you add your first lot, your first dead lot, automatically it adds a self-weight lot with that lot. Okay, so here when we defined our dead lot, it automatically gave us this self-weight. Okay, it will calculate the self-weight for you, the self-weight of this beam. Of course, he will do it depending on the cross-section of the beam and the material of the beam. But we didn't choose that because we will delete this lot. We don't want that. So I will click here. Okay, I will click here and I will click delete. Now I don't have any applied lot, but I have defined a dead lot. Okay, now we just have dead lot. So let's go to applying lot. To apply a lot, let's click on this icon and we can see that we have node lot. So this is point lot. We have member lot. It means that this is distributed lot. Okay, let's go to node. Why? Because in our case, we have a point lot or we have a concentrated lot. As we can see, this is nodal force. So let's choose the first one, nodal force. Here we have some options, X, Z, and moment. So force, we have force in X direction and Z direction. Our force here is vertical, as we can see. So we will apply a vertical lot here. So the vertical direction in robot is Z. So we have to use this one. Okay. In case we want to apply a horizontal load, we will use X direction. And in case if we want to apply a moment, okay, we will use moment around Y. It's clear, right? So yes. So now we have to use this one. And be careful, our load is downward, so we need to include minus sign. It should be negative. So negative 15. And the unit is kilonewton. Let's add that. When we add that, okay, when we add this one, we can choose here where to apply the load. In our case, we only have one element and two nodes. So we can either apply it to a node, one of the nodes, or to the member. But we want to apply it on the center part of the element. In this case, we will go back to nodes and we will add another node in the center. So 3 meters. Let's click here. Now we have another node, node number 3. Now let's go back to load. And again, let's go here, 15, and add this one. And as we can see here, we have this one. If we click here. And now we have number 3 here. Apply to 3. 3 means node number 3. And when we click on apply, we can see this arrow here. So it means that we have applied our load successfully. So be careful about this selection. To be honest, I don't like this type of selection in robots. Sometimes it makes some problems. But anyway, so when you click on something, the selected thing will be written here. So let's say if you select here, it will be here you will see number 1. Here, if you click on this one, you will see number 3. So it will tell you that you are applying your load to number 3, which is our node here. And you will click apply, you will get the load. So now everything is okay, looks okay. We have our support, we have the beam, and we have the point load. What we need to do is we need to do the calculation. Click here in the calculation, but before that I will close this one and I will click on calculation. But before that I will again check my load list. So let's check here. We have a dead load, which is a nodal force, and it's in Z direction, and the value or the magnitude of the load is minus 15 kilonewton. Everything looks okay. Let's calculate. This calculation usually it take a very few seconds, 1 or 2 seconds, because our structure is very simple. But imagine when you have a big structure, this will take a long time, and it depends on the properties of your PC. Now we have the result. How to read the result? To read the result, you will go to result. Here, as you can see, it's written result. When you click on that, you will get another list. You will get another list. Here, I usually use this one, detailed analysis. Click on detailed analysis. And we can get our information from this window here. So you have 3 options because we are in 2D. So we have forces in X direction, forces in Z direction, and we have forces or moment around Y direction. And that's why you have only these 3 active here. The other 3, they are not active, but if you are working in a 3D structure, you will see those 3 options activated too. So if we want to find a shear diagram, or if we want to draw the shear diagram, we can simply click on FZ, the vertical force, and we can click on apply, and here you can see your shear diagram. So we can see it's starting from 10, and actually it's not 10, it's 7.5. Okay, from 7.5 to 7.5. And we can also draw the moment diagram. Check this MY and click apply, and here you can see. So this is the beam, this is the shear diagram, and this is the bending moment diagram. We can improve these drawing here. Parameter, if you click on this part and click on parameter, you can, for example, choose label. You can change this one to be like filled like this one, or maybe this one, as you like. So, and you can get the result. So this is very important to activate this one, so you will get the result. So as you can see here, we have the value of the shear is 7.5, and here it's minus 7.5. Our bending moment, the maximum bending moment, is at the center, which should be at the center in our case, and it's 22.5. In case you want to find the reactions in the support, you can go to result and choose reactions. We can see this window here, and it's clear that we have node number 1 and node number 2, right? So node number 1 is this one, and node number 2 is this one. So we don't have any horizontal reactions. They are 0, 0. And the vertical reactions in node 1, so in this node is 7.5, as you can see here. And in the second node also is 7.5. So as you can see, it's very easy to find the reactions and to draw the moment and shear diagram in Autodesk Robot. I hope this video was useful for you, and if you think so, please subscribe to our channel and like the video. Thank you for watching, and see you in the next video.